So question number 9. So solution X contains 4 metal cations, right? So dilute HCl was added to a small portion of X, so no precipitate. So this is like the first group cation analysis. So there cannot be Ag plus, there cannot be Pb2 plus, and there cannot be Ag22 plus, right? So these things cannot be there. And H2S was bubbled to the solution from the about a black precipitate. Okay, so it could be Bi2S3. So because in the second group you will have 4 different black precipitates: bismuth, copper 2 plus, and mercuric, Hg2 plus, and Pb2 plus. But Pb2 plus cannot be there here, because in the first step we have not seen that precipitate is forming, no precipitate, so this should not come. So in P1, either one of these compounds, P1 was separated by filtration, and the filtrate was boiled to remove H2S. So you can remove H2S there, and ammonium chloride, ammonium hydroxide was added, and green precipitate is formed. So now don't forget, in general, in the cation analysis, first they add nitrate, because to add, if there is Fe2 plus, to oxidize to Fe3 plus. Now here, if there is Fe2 plus, automatically there is Fe2 plus. So this green precipitate can be either Fe2 plus, or maybe the third group, the precipitates are aluminium, chromium, and ferric. From that, chromium is also green. So don't forget, this is also like a dirty green. So this is green. So again, P2 is removed and H2S bubbled. So now this is the basic condition, sulfide precipitation. So here they have obtained a white precipitate. So surely it could be zinc 2 plus, forming the zinc sulfide. Okay. P3 was separated, the filtrate was boiled to remove H2S, cooled, and ammonium carbonate. So this is the last step. So you have added ammonium carbonate. So if that is forming the white precipitate, so it could be calcium or barium. Okay, carbonates, those are white in color. Okay, let's move on to the second step to find. So these are the 4 steps for precipitates: P1, P2, P3, and P4. So we have already found. Okay, one. Okay, let's go to P1. So P1, dissolve in hot dill HNO3, and conc ammonium hydroxide was added, a deep blue color. So automatically we are going to have the answer. So out of these 3, you know, copper will form CuNH4, sorry, NH3 4 times 2 plus. You know this form, tetraamine copper 2 ion. Okay, so automatically this is copper 2 plus. P2, what is P2? Iron or chromium. Okay, let's take. Add diluted NaOH and followed by H2O2, a yellow colored solution. So automatically this is chromium 3 plus. What is the yellow color solution? CrO4 2 minus. Dilute H2SO4 added to the solution 2, it will form. So I have told you this one, this will be in equilibrium with chromium in chromate and dichromate form. So this is the orange species. So we have found copper and chromium. So we have rest of the two. P3 was dissolved in diluted HCl and NaOH was added gradually. So we will have the white color precipitate. So zinc automatically will form the white color precipitate, that is zinc hydroxide, then NaOH twice, and excess addition will solubilize this one to form the complex zinc OH4 2 minus. So these are very simple things. If you are lacking this knowledge, please go through my T-block tutorial in YouTube, then you will get everything. Okay, we said chemically. Okay. So we have identified zinc. So we have remaining with calcium and barium. So P4 was dissolving concave Cl, so it will form calcium chloride or barium chloride, and subject to the flame test. Okay, a brick red flame, so surely it should be calcium, because barium would give apple green color in the flame test. Calcium will give brick red color. So this is, we have identified the 4 cations. Very simple. Okay. Identify 4 metal cations. That is done. Identify the precipitates P1, P2, P3, P4, and P5. So we have given everything here. P5 is zinc hydroxide. Everything is there, right? So P1 is the copper sulfide. P2 is chromic hydroxide. P3 is zinc sulfide. P4 is calcium carbonate. And P5 is zinc hydroxide. Okay. Reasons are not required here. Otherwise, if they ask, you can write all these reasons. In the past, this type of questions, they also ask some reasons as well. Right, that's it. Then have part B. So they are doing 3 different reactions to find the quantitative analysis. So that means concentration of these compounds. Okay, let's check that one by one. 25 cubic centimeter of sample Y. So this is 25 cubic centimeter of sample Y added by barium chloride. Okay. Styrene, after that excess HCl was added with styrene to precipitate the form. Okay, so first they add this one, they styre, and they add furthermore HCl. No further evolution of the gas. Okay, pungent order, which means they say, normally this is diluted HCl. So SO3 2- will react with this one to form SO2 gas. They say here all SO3 is completely removed. So at this point, you need to understand no SO3 2- in the solution. And there is NO3- in the solution at this point. And also barium chloride, when you add here, barium sulfide is formed initially, but the sulfide, when you add this HCl, automatically gives SO2 gas. So it is completely removed. Okay. Try to understand what I am saying. Initially, when you add barium chloride, 2 precipitate will be formed. Barium sulfide and barium sulfate. But when you add HCl here, this is going to dissolve and will give barium chloride, H2O, and SO2 gas. So this is completely, they say evolution of gas is completed, which means there is no barium sulfide remaining. So the only precipitate that is remaining here is barium sulfate. And in solution, you have nitrate. That's it. So they say the solution was allowed to stand for 10 minutes, filtered, then precipitate was washed. So the mass of the precipitate is given. So barium sulfate will be 1.74 grams here. The filter rate of brine was kept for further analysis. So what they are going to do is the same solution, they are going to analyze the nitrate by procedure 3. Okay. To 25 cubic centimeter of sample Y. So again, a 25 cubic centimeter portion is there. So they add H2SO4 along with 5% KiO3. So basically iodate is added. Potassium iodate is added. So this, they say I2 is liberated and it is titrated with sodium thiosulfate. So these are very common things at this point. And the volume and the concentration is given. Okay. Assume that SO3 2- is oxidized to SO4 2-. That should happen, right? Because if I check what is the reaction that is happening here, basically what is happening here, IO3 minus is reduced to I2. In the same way, on the other hand, SO3 2 minus is oxidized to SO4 2 minus. Okay, so don't forget, you need to balance this one, 2 iodines and 6 H2O to balance the oxygens, and to balance the hydrogens there will be 12 H plus. Then you need to put the electrons based on the charge. So here there is no charge. Here there is 12 H plus and 2, so 10 something. So I can add 10 electrons here. Okay. The same way, sulfur is there, oxygen is there, so there is only one oxygen that is you need to add one H2O molecule to balance the oxygen here, and here on the other side you can add 2 plus, and here there is no charge here. 2 minus 2 plus is neutral, 2 minus, so I have to add 2 electrons here. Okay, this is the common reaction that is going to happen in procedure 2, right? So this is procedure 1. What is happening? This is procedure 2. So let's go to procedure 3. The filter rate from procedure 1. So you have in this filter rate, you have now NO3 minus. So it was neutralized because they have added HCl. So there can be some excess HCl. So because they have added excess diluted HCl. So first you need to neutralize, and they say then they add aluminium powder and dilute NaOH. So you should remember what is going to happen now. So if you're familiar with this reaction, you automatically know from this NO3 minus what is going to happen. Ammonia is going to form, to remember. And the solution was heated and the gas was evolved. So gas evolved. Transferred quantitatively to react with 20 cubic centimeter of 0.11 m HCl. Give me a second again. And so this was passed through this amount of HCl, and some of the gases that is coming out from this particular reaction is going to react with HCl. And then the remaining HCl is going to react with NaOH. So first thing is you need to understand what is actually happening here. So as I told you before in my previous discussions also, if you really want to keep this equation, you can keep this equation in mind where you know NO3 minus react with aluminium, and in the basic medium OH minus will give this AlO2 minus plus ammonia. Okay, otherwise now you need to balance this one. So if it's difficult, if you want to remember each and everything. So this is one of the reaction that is happening in this one. The next reaction that is happening is ammonia titration with HCl. So ammonia is also going to react with HCl to form this ammonium chloride, NH4Cl. Right. Furthermore, the remaining HCl is also going to react with NaOH. Okay, NaOH to give NaCl plus water. Okay, these are very simple things. Now, how do you balance this one? So, if you are very little in knowledge, so I can give you what is actually happening in the basic form. Basically, NO3 minus is reduced to ammonia. This is the first reduction reaction, half reaction. And aluminium is oxidized to AlO2 minus. Okay, in the basic medium. So based on these two, you can balance and write down the reaction. That is the easiest way if you don't know the reaction. So nitrogen, 1 nitrogen, 1 nitrogen, 3 oxygens. So I am going to add 3 H2O here. So you remember our method, the basic medium. Then to balance the hydrogen, so here there are 6 hydrogens, 3 hydrogens, so 9 hydrogens. So I am going to add 9H plus and 9 OH minus to the side. So basically we try to balance like the acidic condition. So I add 9H plus, then I add 9 OH minus to this direction and 9 OH to the other side as well. Okay, and 9 OH plus 9 H plus means 9 water. So there are 3 water here, so I can cut this one and cut these 2 here, and the rest balance is 6 water molecules here. And I have balanced the atoms now. Then I have to balance the charges. So here I see 9 electrons. 9 electrons mean 9 minus, here 1 minus. So to balance, I can add here 8 electrons. And in the same way, aluminium to yellow to 2 oxygen. So I can add 2H2O in this side and 4H plus and 4OH minus. So why I am adding OH minus as well? Because this is in basic medium, NaOH. So here in this side also I am going to add 4OH minus. So 4 water molecules to 2 water molecules, or there will be 2 water molecules here. And charge is here 4 minus, here 1 minus, so I am going to add 3 electrons here. Then to balance, so this should be like multiplied by 8 to balance this one. So this should be like 8 stoichiometry. This should be balanced 8 aluminium. This should be balanced by 3, so 3 nitrate. So the stoichiometric ratio is 3:8. So that is the important thing that you need to know here. Okay, the stoichiometric ratio is 3:8 with respect to NO3 minus to aluminium. Okay, right, write the balance ionic non-ionic equation for the reaction. So you need to write all these reactions here. That is done. Determine the concentration. So based on this stoichiometry and balancing, you can automatically find the concentration. Now that is not a point, right? Because here you have the weight of barium sulfate. Then you can divide this by the molecular weight of barium sulfate to find the number of moles. That is the first step. Then if you know the number of moles, what you can do here, you know the solution volume, that is 25 cubic centimeter. So you divide it by 25 into 10 to the power minus 3 to get the concentration in MOLDA minus 3. Okay, so that is done. In the second step, you have given the amount of sodium thiosulfate required. So 20, 0.02. So you find the amount of sodium thiosulfate. So additionally, there is this reaction, this sodium thiosulfate with I2 will give NaI, that is 1, plus Na2 S4O6. Okay, this is Na2 S4O6, sodium thiosulfate to sodium tetrathionate. Okay, so there are 2 sodium, so I can put 2 here and add 2 here. So 2 NaI and Na2 S4O6. So 2:1 ratio. So you can find the number of moles of sodium thiosulfate. Half of it would give I2. And if you know the amount of I2 based on this stoichiometric relationship, you can find, you need to first balance this one. So you multiply this 2 by 5. Then you can balance this to 10 electrons. So you know the amount of iodine, which means you know the amount of sulfite. And you can automatically find the concentration of sulfite as well. This done. And in the last step, it is also very similar. So you have the initial amount of HCl. You know the remaining amount of HCl. So subtracting the initial amount from the remaining amount, then you can find the amount of HCl that is reacted with this ammonia formed. And when you know the ammonia formed amount, you will automatically know the amount of nitrate formed. Okay, so these are very simple things. Give that color changes that would be observed in the titrations in procedure 2 and 3. So this titration is a titration where we use the indicator starch. So here the color change would be blue to colorless, Okay, and here in the third procedure, that is acid-base titration. Okay, so here you see here the remaining amount is titrated with HCl and NaOH. So you will have HCl in the solution. So basically this color change will be red to yellow. Okay, this is the color change. Because in the titration flask, initially you have HCl. So when you add methyl orange to this one, the initial color will be red. And you are adding NaOH from the top. So adding, it goes to about the pH range and it will turn to yellow and you stop the reaction. That's it. So this question is not hard. It is very simple and easy. Yeah.